Today, in this session, we discuss what is Bronsted Lowry neutralization and some common conjugate acid-base pairs we will see. Okay, first one, what is neutralization of Bronsted Lowry theory. Okay, first we will see what is Bronsted Lowry acid. Okay, from this theory, proton donor we are calling Bronsted Lowry acid. Okay, proton acceptor is Bronsted Lowry base. Okay, here what is Bronsted Lowry neutralization we are seeing. The transfer of proton from an acid to the base is known as neutralization. The transfer of proton from an acid to the base is known as neutralization or protolysis in the reaction, or protolysis in the reaction. Okay, one more important point: a pair of acid base which is differ by a single proton is known as a conjugate acid base pair. A conjugate acid base pair. Okay, now we will see few common conjugate acid base pairs. Okay, list of some common conjugate acid base pairs. Okay, see here we will see few examples. Okay, how we can find here? Okay, that suppose acid produces proton and H plus ion, proton and base. Okay, it produces H plus ion and become conjugate base. Okay, and the base means base which can accept a proton to become conjugate acid. Here we will see few examples, what are the acids and what are the bases of Bronsted Lowry theory concept. For example, perchloric acid formula is HClO4. Its name is perchloric acid. Okay, when lose this proton to become ClO4 minus, this name is perchlorate ion. perchlorate ion. Okay, next hydrogen bromide, HBr. Okay, this one we are naming as hydrobromic acid. Hydrobromic acid. When it loses proton to become Br minus, this is Br minus is bromide ion. Next, HCl already we discussed. HCl is hydrochloric acid. Cl minus chloride ion. Okay, acid becomes conjugate base. Cl minus is conjugate base of HCl. Okay. Similarly, we will take H2SO4. This is sulfuric acid. Okay, when it loses one proton to become HSO4 minus, this is hydrogen sulfate ion. Okay, this hydrogen sulfate ion also, okay, again produce proton to become SO4 minus. Suppose this one we are taking here, SO4 minus, it is producing H plus ion to become SO4 minus 2. Okay, here hydrogen sulfate ion, okay, become SO4 minus 2 sulfate ion. Okay, here in this condition we can see here HSO4 minus is act as acid as well as base. Okay, clearly we are discussing here how it is. Suppose the ion is HSO4 minus, which can accept the proton, okay, to become H2SO4, and which can remove proton, that means donate proton, remove proton, okay, to form SO4 minus 2. In this direction we can see which one accept the proton. Okay, it is act as a base, this condition it is base. Okay, it is conjugate acid, this is conjugate acid, and in this direction we are removing proton, that means it can act as an acid. This direction it can act as acid and become a conjugate base, to become conjugate base. Here from this example, this HSO4 minus hydrogen sulfate ion can act as acid as well as base. This type of substances we are calling amphiprotic substances. Amphiprotic substances. It can act as both acid as well as base. Okay, we will see few more examples. Okay, formic acid. Okay, formula is HCOOH. This is formic acid. Okay, it gives COO minus HCOO minus formate ion, next acetic acid CH3COOH, okay. When it releases proton, it becomes CH3COO minus, CH3COO minus. This is acetate ion, okay. Next ammonium ion, NH4 plus. This is ammonium ion, okay. It produces proton and become NH3. This is ammonia. And next example, water, H2O. Water releases proton and become OH minus. This is hydroxide ion. Here we will see OH minus also can act as both acid as well as base for adding proton, okay, to become H2O, and removing proton, okay, to become O minus 2, okay. This direction, this is addition of proton, it is act as okay, base, and they become conjugate acid, and here donating proton to become acid, it can act as acid and become conjugate base, Here OH minus also can act as both acid as well as base. This is also amphiprotic.